Alright, welcome to Best Academy TV. In this video, I'll be teaching us on the topic wave. Okay, so we are going to know what wave is. We are going to know the wave parameters and also their calculations. Okay, and also we are going to solve some questions on wave. All you just have to do to get all the exam possible question on wave is to click the subscribe button to get all the exam possible question on wave. Okay, but let's start with the definition of wave. Okay, please write. Wave can be defined as a disturbance. Please write as a disturbance which transfer energy from one point to another without any displacement of the medium, without any permanent displacement of the medium. Okay, now in definition of wave here we have 2 points. Wave is a disturbance, and it does not allow the displacement of what? Permanent medium. Please take note of that. Okay, so what you have to do here is to know these two here and everything will be set in terms of wave. But the next question you have to know here in terms of wave, in terms of definition of wave, is what energy does wave transfer? What energy does wave transfer? Now this energy is said to be kinetic. Please take note. The energy that wave transfer is said to be kinetic energy. Okay, those are some exam possible questions in terms of wave. Okay, the next thing here, please write waves and wave parameter. Wave and wave parameter. All right, class, let's consider wave parameters here. Number one, amplitude. Please write. Amplitude can be defined as the maximum displacement of wave. Amplitude can be defined as the maximum displacement of wave from the point of equilibrium. Amplitude can be defined as the maximum displacement of wave from the point of equilibrium. It can be denoted as A or small letter A. It can be denoted as A or small letter A. Please think of this. It is measured in meters. It is measured in meters. All right. Let's look into the diagram of amplitude here, the diagram of wave, to identify amplitude. Okay, some question they will give us the diagram and they will enable us to identify some of the parameters and use that parameter to solve the equation. Okay, now class, this is the diagram of wave. This here, from here to here, is said to be amplitude. Please take note. Now amplitude is not found at the top only. Remember, amplitude can also be defined. This can also be defined as the point of equilibrium to crest, or the point of equilibrium to trough. It's also amplitude. They might not define amplitude to be maximum displacement. The point of equilibrium to trough, or the point of equilibrium to what? Crest, is also what? Amplitude. Okay, so this is from here to here is said to be amplitude. Okay, but this top here we call it crest. This top here we call it crest. This top down here we call it trough. Please take note. Okay, let's consider the next parameter here. The second parameter here is said to be wave length. Wavelength, let's take a note here, please. Wavelength can be defined as the distance covered by wave. Wavelength can be defined as the distance covered by wave. Okay? It can be denoted as lambda. It can be denoted as lambda. Whenever I see this sign here, it's telling us more about what? Wavelength. Please take note. It is measured in meters. Now from this sketch here, we can also define wavelength. From this sketch here, please. From the sketch here, we can also define this wavelength here. From this point of origin here, to this point here, from here to here is also wavelength. Please take note. So what does it mean here? From the sketch here, we can define wavelength as the distance covered by wave in a circle, in one circle. The distance covered by wave in one circle. This is one circle here. This is half of a circle. This is half of a circle. Add this together, you have a what? A circle. So the distance covered by wave in a circle or in one circle is what? Wavelength. Please take note of that, okay? So to here, okay, is one wavelength, okay? Please take note of that, okay? Now that's the next parameter here. Now let's take the next parameter here, class, and period. Period can be defined as the time taken. Period can be defined as the time taken to cover one complete oscillation. Period can be defined as the time taken to cover one complete oscillation. Okay? Now it can be denoted as T, that's capital letter T. Can be denoted as T. Now let's look into the mathematical expression of period. Okay? All right. Period can be denoted as capital letter T. That is T here. Please take note. Okay. Now the next thing to look into here is the mathematical expression of period. That is T. Now let's look into all the mathematical expression of T. The first one we are going to look into here is the mathematical expression of T relating to number of oscillation or vibration. Okay. So that means T, mathematically, T is equal to small letter T over M. Now, this small letter T here is said to be time taking. Please take note. This small letter T here is said to be time taking. This M here is said to be number of oscillation or number of vibration. Please take note. Number of oscillation or number of vibration. Please take note. Where T is equal to time taking, M is equal to number of oscillation or vibration. Please take note. Now, whenever you are given number of oscillation or number of vibration, you're asked to find period. This is a mathematical expression you have to use. All right. Now, let's use the next one here. Let's take the next formula in terms of period. Okay. Let's take the next formula in terms of period here. The next formula is said to be T is equal to 1 over F. Now, this is the formula of period relating to frequency. Please take note. Where F is equal to frequency. Okay. Now, this is the next formula here. That is F is equal to frequency. So, if you are given frequency and you are asked to calculate period, the formula to use is 1 over F. So, the next one here is the formula for period relating to angular frequency. That is 2 pi over what? Omega. Please take note. That is 2 pi over omega. Okay. Now, this is the formula for period. This is the formula for period relating to angular frequency. Now, this omega here is said to be angular frequency. I'm going to explain this omega more in the next formula. Please take note. Okay. Now, where omega is equal to angular frequency. Okay. Now, let's take the next parameter here, which is formula 4. Now we have frequency. Please write. Frequency can be defined as the number of time taken to cover one complete oscillation. Frequency can be defined as the number of time taken to cover one complete oscillation. Take note of this. Frequency and period is not the same thing. Now, period starts with the time taken to cover one complete oscillation, while frequency starts with the number of time taken to cover one complete oscillation. Please take note of this, okay? Now, let's look into the mathematical definition of frequency. But before then, let's write down here. Frequency can be denoted as F. Frequency can be denoted as F, and it is measured in hertz. It is measured in hertz or per seconds. It is measured in hertz or per seconds. Okay. Now let's look into the mathematical expression of frequency. But to make everything short here, we should understand this, that frequency is the inverse of period. So if you can know the mathematical expression of period, you can also know the mathematical expression of this class frequency by inverting their formulas. Please take note, okay? Now let's look into the mathematical expression of frequency here, please. All right, class, let's look into the mathematical expression of frequency here. The first one here, class, is said to be F is equal to 1 over T. Now, this is the mathematical expression of frequency when period is given to us, where T is equal to period, okay? Now, the next one here is said to be F is equal to N over T. This is the mathematical expression of frequency when number of oscillation is given to us. Please take note. Where N is equal to number of oscillation or vibration. Please take note. Now the next one here is said to be frequency relating to angular frequency. Please take note. That's F is equal to omega over 2 pi. F is equal to omega over 2 pi, where omega is equal to angular frequency. Okay, now this letter omega here is somehow confusing to students. Now sometimes the omega is called angular frequency, sometimes some topic is called angular velocity. So let me try to make you guys to be clear about this. Now omega can be called depending on what you are relating it to. If you are relating omega with frequency, you call it angular frequency. If you are relating this omega here with velocity, we call it angular what? Velocity. Like from this formula here, V is equal to omega R, like this from your secondary school. Remember? Now, I'm relating this omega here with velocity here. That means I have to call this omega what? Angular velocity. Okay? Now, I have explained this in our previous video. All you just have to do is to watch at circular motion and understand more about this here. Okay, or you hit the subscribe button to understand to get notified from all our video. Okay, now from here, this omega here is called angular frequency. So at this point here from here, this omega here is related to frequency. So at this point here, we replace this omega with what slash angular frequency. It's related to frequency. That means I'll call this omega what? Angular frequency. Please take note. So these are the formulas relating to frequency. All right. Now let's look into the next parameter here. Please write wave. Right.